All right, let's just get right to it. You've built this amazing AI app, but is it kind of slow and maybe a little expensive? Yeah, if you're nodding your head right now, you are in exactly the right place. Today, we are opening up the playbook on modern AI response caching. We're going to show you how to turn those slow, expensive API calls into lightning-fast, cost-effective responses. So let's get into it.
Okay, so Section 1, the high cost of repetition.
You know, this is about more than just the money. Even though, let's be real, cutting down on those API costs is a huge win. It's also about speed, or, latency, getting rid of those annoying delays for your users. And it's also about consistency, right? Making sure the AI gives the same correct answer every single time someone asks. Caching, it tackles all three of these head on.
I love this analogy. Think of caching like a really good bartender who remembers a regular's drink order. The first time you walk in, they have to ask. But after that, the drink is on the bar almost before you sit down. That's what caching does. It's your app's short-term memory. The first user asks a question, the AI does the heavy lifting, and the cache saves that result. Every single person who asks the same thing after that, they get an instant and basically free response. It's so simple but so powerful.
All right, let's move on. Section 2, a spectrum of strategies.
Okay, let's kick things off with the most straightforward approach out there, exact query caching. And yeah, the name pretty much says it all. This is the simplest, fastest way to get started.
So the logic here is super simple. You take the user's exact query, word for word, character for character, and use that text as a key in a database, something like Redis. If that key already exists, bam! You just return the stored response. It is incredibly fast. This is perfect for stuff like an FAQ page, or maybe some fixed dashboard queries where the input never ever changes. But, and this is a big but, here's the catch. It's too precise. If a user adds a comma or misspells a word or even just changes one little thing, the match fails and it's a cache miss.
And when you look at the code, it's just as simple. Now, don't get bogged down in the syntax here. The logic is what's important. All it's doing is asking a simple question. Have I seen this exact question before? If the answer is yes, it just grabs the answer from the cache, super fast. If the answer is no, then it makes that expensive call to the AI, and it makes sure to save the answer for next time.
And that brings us right to the big challenge, doesn't it? What happens when one person asks, what were our profits last quarter? And someone else asks, hey, show me last quarter's profits. I mean, the intent is identical, but that exact caching system we just talked about, it would miss it completely.
So to handle that, we've got to get a little cleverer and try to anticipate those small variations. And that brings us to our next strategy, paraphrase-based caching.
Here's the idea. You actually use an AI model ahead of time to generate, say, 10 or so different ways a user might ask a really common question. Imagine a CFO asking for a financial report. You come up with all the likely variations. Then you stored all of those paraphrases as keys, and they all point to the very same answer. It's a really clever trick for predictable queries, but as you can probably guess, it just doesn't scale very well. There's no way you can predict every single variation for every possible question.
So what we really need is something smarter, something that understands the meaning, the intent behind the words, not just the literal text. And this is where embedding or semantic caching comes in. This is a total game changer.
Okay, this is where things get really, really cool. Instead of storing the text of the query, you convert the query into what's called a vector embedding, which is just a fancy way of saying a list of numbers. Think of it like a coordinate that pinpoints the query's meaning in a giant map of ideas. You store these vectors in a special vector database. Now, when a new query comes in, you convert it to a vector too, and then you just search for the closest existing vector in your database. This is absolutely perfect for SaaS products where, users are going to phrase things in a million different ways.
And this bit of code really shows that core idea in action. It generates an embedding for the new query, and then it goes through the stored embeddings and calculates their cosine similarity. Just think of it like measuring the angle between two arrows that are pointing to different ideas. If the angle between them is super tiny, it means their meanings are almost identical. And boom, we've got a match. We can serve the cache response without ever having to bother the big, expensive AI.
Okay, let's shift gears for a second. So far, we've been totally focused on caching questions from users. But what if the expensive AI task isn't triggered by a user at all? What if it's a recurring report your own application runs on a schedule?
This leads us to our fourth and final strategy, application-level caching. You could also call it business-level caching. The key here is being proactive.
So instead of waiting for someone to ask for something, you pre-compute these complex, data-heavy results. We're talking about things like a quarterly P&L statement or a list of the top sales leads or some really complex analytics. You cache the entire finished report. And the real magic here is that you only need to rerun the AI and update that cache when the underlying data actually changes. This makes it incredibly efficient for stuff that gets looked at all the time, but maybe only gets updated once a day or once a week.
All right, Section 3, keeping your cache fresh. This is important.
Because, let's face it, a cache with stale, outdated data is actually worse than having no cache at all. So here are the pro tips for keeping it fresh. First, event-driven invalidation is the gold standard. When the source data changes, you update the cache. Simple. For data that changes more often, you can use a time to life, or TTL. It just puts an automatic expiration date on the data. Now here's a really clever trick. Include the AI model version in your cache key. Why? Because that way, when you update your model, you don't accidentally serve old answers from the old model. And finally, you have to monitor your cache hit ratio. It's the single best metric to see how much money you're actually saving.
Okay, let's bring it all home. Section 4, Benefits and Recommendations.
Think of this table as your cheat sheet. You've got exact caching, super fast, but its coverage is limited. Paraphrase caching covers those predictable variations. Embedding caching is the most flexible by far, since it captures semantic meaning. And then you've got business-level caching, which can save you the most money when your data is stable. But you know, the real power? It often comes from mixing and matching these strategies to get the absolute best return on your investment.
So here it is, the bottom line. Use exact caching for your FAQs and any static dashboards. That's a no-brainer. Use paraphrase caching for predictable business queries, maybe in a financial SaaS app. You should absolutely go with embedding caching for any app where your users have the freedom to ask questions in their own words. Think of a CRM. And finally, use application-level caching for those big, heavy, pre-computed reports. A smart hybrid approach here is going to give you a massive boost in both performance and savings. It's a win-win.
So, there you have it. We've walked through the problems, the different strategies, and the best practices to keep everything running smoothly. The playbook is officially in your hands now. So the only question left is, which one of these powerful strategies are you going to implement first to make your AI app faster, cheaper, and a whole lot smarter?